Guys, Mrs. Dan's here. So we're starting a new unit today. It's called Statistics. By looking at the homework board, you can see that it's a short unit and we will be taking a test that last day before we go on break, April 18th. If you could just put your name on your workbook and copy the objective onto the lines. I will do the definitions with you for the do now. I will show you this objective in a little bit again. I just want to show you what your homework is as well. So in class, we're going to go over the do now and do the development together. At the end of the class, you'll be able to tell me what a scatter plot tells us. Your homework is Lesson 1's problem set, which is pages 3 and 4. So here's your objective again, written down on the lines. And we are going to be comparing two sets of data, and we're creating something called a scatter plot. When we make a scatter plot, it helps us decide if there is a correlation, and we'll talk about in a few minutes what a correlation means. We're going to determine if there's a linear correlation, a nonlinear correlation, or no correlation. And hopefully some of those words are sounding familiar, right? We learned about linear and we learned about nonlinear. So what the heck is statistics anyway? So statistics really is just gathering data and displaying it visually to help make predictions. Now I'm going to try and go slow enough so that you have time to copy all of this, but please tell someone to hit pause if necessary. Don't let something pass you by. And when you're done copying what statistics is, you can then copy what a scatter plot is. Really, it's a comparison of two lists of data, and we represent them as points. So we already know how to plot points, so you'll see that today is pretty easy. So maybe you've actually wondered this. Maybe you've been curious to know if one event is related to another, such as, if I study longer, will I get a better grade on my final exam? So some people think that answer is yes. Some people maybe, I guess, don't care. But you can gather data about things you're curious about and make a scatter plot to see if one event really is related to another event. They do this all the time when they're creating medicine, even with medicines that they think maybe will help some kind of sickness. They have to gather data. They have to see how soon different people get better from taking the medicine, or even if the people get better at all. And it gathers so much statistics to see if this is a worthwhile drug to put on the market. Does it really help? And there are plenty of things that they gather data about. Nowadays with our cell phones, every time we click on something, they're gathering that data. People know what websites certain age people visit. And that's how come like certain ads even appear on other websites you visit. It's all about gathering data, and someone wants to gain something from the data gathered. So notice here that statisticians, they try to gather data so that they could determine if there's correlations. Now, correlation really is a relationship. So maybe you want to underline this or highlight it. A correlation represents some kind of relationship. And a scatter plot, since it's about a comparison of two lists of data, we call it bivariate data. You know the prefix bi means two, so two lists of data means that we have bivariate data. So let's see some data about studying and your final exam grade. So this is some data Of course, there are more people who have taken final exams, so we call this a sampling of data. It's a small group of people and found out how many hours they studied and what their final exam score was. I think this second to last 1 hour of study, if you could cross off the 40 and make it a 60, I think that's more realistic. And you can see that I've already plotted my points. If you can do the same thing, we know how to plot points because remember, this is your x-axis, this is your y-axis, so this is the point 3, 80. And you can see where I put it. Here's 3 and 80, and I put a point. So don't copy the points from the board. That's difficult to do, to look up and look down. Just look at your table and please plot the points. And I'll wait for you to catch up to me. So I'm going to continue, but again, please, if you didn't finish plotting the points, raise your hand, tell them pause the video. So after all these points are plotted, we can look at them to see if it seems like there's a relationship, right? This is what this is asking. Does it seem like there's a relationship? And the way that we determine if there seems to be a relationship is by the path of the points. If the points are making some kind of path, then there is a relationship. So when we say, is there a relationship or is there a correlation, I want you to look at the path of the points. Write this down, please. If there's a distinct path, then there is a correlation. If there is no path, if the points were just completely scattered all over the place, then there would be no correlation. So do you agree that there is a path to these points? Do you agree that it seems like as we go to the right, it's going upward? Notice I didn't connect these points. We really don't connect them. We don't want this jagged line. We want to look at just the path of the points and see if it's following a certain trend. And this looks like it's going upward to the right, which means it looks like the more hours you study, the higher your grade is. So I would say yes, there's a correlation. Then it asks if there's a correlation, is it linear or nonlinear? So do you agree that this path of points seems to follow a straight path going upward? You'll see on the next one what a curved path looks like. It's clearly curved. I know this isn't a perfectly straight line, but if I could, don't draw these lines, but if I could, put some kind of boundary lines on each side, don't you see this is like a path, kind of like a sidewalk that you would follow. It is straight. These points are going in an upward, straight direction. The path of the points is linear. So we'll say it's linear. And the reason why is because it's following a straight line. Now, if you have any questions, maybe someone in the room would be able to answer your question. Maybe another student, maybe Miss Halton or your sub. So just pause the video if necessary. Otherwise, let's move on to the next page. So now we're going to look at another 2 sets of data. We're going to compare the car speed to the gas mileage. And we're going to construct a scatter plot. I want to put the speed along the x-axis, if you could write speed. I'm going to put an arrow here too. And I want to put mileage along the y-axis. Now I want you to make your scale like mine. When I look at the speed, I decide that I want to actually go by fives, but I'm not going to label every 5. I'm going to label every other. So if this is 5, this one's 10, 15, 20, and so on. If you can label your x-axis for me. Now when we do our y-axis, I notice that the lowest number is a 22, while the highest number is a 32. Those numbers are pretty close together. So when numbers are close together and they don't go all the way to 0, you can do something that's called putting a break in your line. So starting at the origin here, I'm going to put a little zigzag. I went up to my second mark. So this break in the line shows that I'm skipping a bunch of points or a bunch of numbers. And I actually want to start at 20 and then go by ones. And the highest number was a 32, so I'm going to stop at 32. This just allows my data to be a little more visible. It's kind of like zooms in when I put this break in the line. I would have been allowed to start at 0 if maybe I went by 2s, and I could do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, and I would have made it, but my points would have been kind of squished together. So a good reason for doing a break is when you don't have any data below a certain point and then you just want to go by ones. Sometimes putting a break in your line can be misleading though. So there are certain instances where maybe it's not good. In this instance, it will be fine. So if we could just plot these points, remember speed is your x and mileage is your y. And I'm going to do this at the same time as you, so you'll probably finish right along with me. So remember, we do a scatter plot to see if there's a correlation. Remember, a correlation means that we see a path to our points. Do you agree that there is a path that's going upward and then downward? I think that there is a correlation because there is a path that these points are following. So does there seem to be a relationship or a correlation between car speed and gas mileage? The answer is yes. There is a clear path. If there is a correlation, which there is it linear or nonlinear? By looking at this, does it make a straight line? The answer is no. So there's a nonlinear path to the points. I'm going to say the path is not a straight line. So correlations can be linear and they can be nonlinear. If I were to interpret what this could mean, it seems like when I'm going a slow speed, my mileage is rather low. When I'm going a medium speed, the mileage is pretty high. When I'm going a real high speed, it's back down to being low. So that's what the data shows. Scary if they really tracked someone going like 100 miles an hour. But anyway, here is a scatter plot already done for us. It's about a trucking company, and it keeps track of the number of miles that each of its drivers log, right? So truckers, they are on the road for lots of hours at a time, which means that they go lots of miles. And they were comparing the driver's age and the number of miles that the driver drove. So when I look at this, does there seem to be a path that the points follow? When I look at it, it looks like it's just scattered all over the place. And if we think about it logically, I mean, in order to be a trucker, you have to be allowed to drive. So I guess you're over 18. But of course, you can be any age. Do you really think that you're only going to drive a certain number of miles when you're 18 versus when you're 30 or versus when you're 40? I think not. I think a 40-year-old can drive the same amount as a 20-year-old, can drive the same amount as a 50-year-old. So your age does not affect the number of miles that you drive. Definitely does not. So that's why it's so scattered. So does there seem to be a relationship? No correlation is what I'll say. It says, if there's a correlation, is it linear or nonlinear? There is no correlation, so this is a question we don't answer. So, moral of the story, what scatter plots is for is to compare two sets of data to see if to see if two things have something in common, to see if there's a relationship between them. If things have something in common, the points will make some sort of path. Sometimes the path will be linear. This one is an increasing path, so we would actually say this has a positive correlation. Some relationships are nonlinear, like this speed and mileage one. And some things really don't have a relationship. It's like a silly thing to maybe even plot. But you know what? Sometimes we're not sure if there's a relationship until we actually gather data and start plotting it. Some other things that I could just think of that maybe have relationships would be, what about the temperature it is outside and the number of layers of clothing that people wear? Don't you agree that as it gets hotter, we wear less layers of clothing, but as it gets colder, we wear more layers of clothing, like we'll have a winter coat and a scarf and a hat and gloves. So I would say that there's a relationship between the layers of clothing and the temperature outside. If we were to plot that, I think we would see a path to our points. But what if I were to think about how old a person is and how many pets they have? Do you think the older you get, the more pets you have? Or the older you get, the less pets you have? I think that's absolutely, neither one of those is true. I think there's no correlation to your age and the number of pets you have. Me, you know me, I'm old. I'm 48 years old. I have one pet. Guess what? I have an 18-year-old that lives in my house. So she also has one pet. So the age doesn't affect how many pets you have. Some of you sitting in a classroom might have one pet, might have 10 pets, might have 0 pets. Your age doesn't affect the number of pets. So if you were to plot that, you'd see scattered points all over the place. So we would say that situation has no correlation. So your homework is going to be pretty easy. You're going to be plotting some points. You're going to be deciding if there's a correlation. And if there's a correlation, you'll tell me whether it's linear or nonlinear. So you can start your homework. Maybe you'll finish it. If not, please finish at home. Have a good day. See ya. Bye.